In this video, we are going to walk through an example for a hypothesis test on a difference of means from two independent populations. And we're going to calculate the test value and p-value by hand using the fact that we have an idea of what the underlying distribution in theory, the distribution of sample means, should look like. And so the example I want to take a look at here is do male nurses earn more than female nurses? Or in other words, do female nurses earn less than male nurses? So that's the claim that we're testing. Down here we can see that. And so with that in mind, we can set up our hypotheses right away. So usually researchers have a claim like this. And the first step is setting up your hypotheses. So in this case, the null hypothesis is always going to be there is no difference. So in this case, it would be that mu sub female, for example, minus the mean salary for male nurses, mu sub m, is going to be 0. There's no difference in the pay that these two groups make. And we would test this compared to the alternative hypothesis, which is going to say there is some difference here. And it might be a claim that one is less than the other, greater than the other, or just not equal to each other. And so that depends on what they're trying to gather evidence to support. And in this case, it's that the salary for female nurses is less than male nurses. So that would make this difference negative. So the claim is that the difference in those two means should be negative. And it's worth noting at this point, because of this less than symbol, the way that I've set up these hypotheses, I'm going to need to do a left tail test. And let me just say, you could very well have set up these hypotheses in an equivalent manner, like saying mu sub f is less than mu sub m, or you could have said that mu sub m minus mu sub f is greater than 0. So there's not a unique way of stating these, but at the end of the day, they should all be consistent with each other. So now we've got our hypotheses. And so the next step is to calculate the test value and then the p-value, and that's going to depend on the samples that we've collected. And so what we've collected from this survey is 16 male nurses and 20 female nurses responded to the survey. And out of the 20 females, they had a mean salary a little over $23,000 with a standard deviation of 250. And from the group of 16 male nurses, we can see that that salary was greater than the female salary, and it had a standard deviation of 300. So the real question is this difference that we observed from our two samples big or is it small? So I can see that it's like actually $150 difference, but I don't know whether I can attribute that difference just to the sampling process, or maybe that difference is beyond what's reasonable to expect from the sampling process. And that's what the test value is going to measure for us. So for the test value, we're going to use the following formula that for t. Okay, so recall what the formula is. We would have that t is equal to the observed difference, so that's x bar f for female mean minus the mean salary for the males, and then we divide that by our approximation for the standard error, which is going to be the standard deviation for females squared over the number of females plus the standard deviation for the males squared over the number of males, and then we take the square root of that. So for the females, the mean salary was $23,750, and for the males, that was $23,900. And so we have a difference of $150 that we then want to describe this distance in standard units of how many standard errors. So we divide by 250 squared over 20 for the females, 300 squared over 16 for the males, and then we take the square root of that sum, and that tells us a test statistic of minus 1.604. So what that tells me is our observed difference is a total of 1.604 standard errors below what we should expect the difference to be, which is 0. And so the p-value is going to be how likely are we to get a sample or samples with means that are even bigger than the observed. So we want to find the area to the left because we had a left tail test. And so when we're looking at this distribution, just remember it might seem like a normal distribution, but because we don't know the variance of either populations, then in this case, what we actually need to do is use a t-distribution in this case. And for t-distribution, we need to identify what are the degrees of freedom. And so here we're going to pick the smaller of the two sample sizes. So one sample was size 16, one sample was size 20. So in this case, this means we're going to use a t-distribution to find the p-value, and the degrees of freedom are going to be 16 minus 1, which is going to be 15 degrees of freedom. So that calculation, we can either use a table, a t-distribution table, and look across the row corresponding to 15 degrees of freedom. If we want to use R, then the function we would use is the PT function. And first we would enter our value of minus 1.604. And then we need to enter the degrees of freedom, which in this case, again, was 15. And checking this output from R, this is approximately 0.065. So what this p-value is telling us is that if the null hypothesis were true, if there truly was no difference in the salaries that male and female nurses make, there is a 6.5% chance of getting a difference in means that we observed from our two samples. And so now when we want to make a formal decision about this, if we're using a 5% significance level, which we're told to use over here, then we compare our p-value that we found in the previous step to that significance level. And what we can see here is that our p-value is bigger than that 5% significance level. And so when that happens, we fail to reject HO, and therefore the test is inconclusive. And if we're using this to make some decision whether female nurses make less than male nurses, we can't claim that they do, we can't claim that they don't, but we have not gathered enough evidence to support our claim. So we cannot claim that females earn less than males. We can't claim that they make the same amount either. This is just an inconclusive test result. So that's how we can run a hypothesis test for a difference of two means using the theory that of the central limit theorem, as opposed to like permutation tests that we did earlier in the semester.